Sharing my screen first. Okay, then let's start. So, hello to all who will be watching this video, and this video presentation is my laboratory exercise number 7 in Signal Spectra and Signal Processing Lab. So, the title of this is Sample Theorem and Aliasing. So, again, I am Merit A. Lucero, 2019-333, a BSECE student of LPU Laguna. So, let us go with the laboratory exercise. Okay, so the objective of this is to show a spectral plots of signals with and without aliasing. So let us first define what is this sample theorem and aliasing are. So sample theorem is the sampling theorem specifies the minimum sampling rate at which a continuous time signal needs to be uniformly sampled so that the original signal can be completely recovered or reconstructed by these samples alone. These are usually referred to as Shannon sampling theorem in the literature. On the other hand, aliasing is a phenomenon fundamental to digital signal processing and can theoretically occur in both the phase encode or frequency encode directions. We will not be detailing these informations, and because we are minimizing the time that will be consumed in this video, and these topics is mostly detailed discussed in our theoretical subjects. So let us go with the laboratory exercise guides. So the following exercise will show the basic concept of sample theorem. So we have here a two item. So first is the concept of sampling and aliasing. Then the other one is the aliasing using convolution in frequency domain. So for the first item, we will try to analyze the codes that have made into this. So we have here the fs1 is equal to 100. This is the sample frequency in terms of hertz, which is 100. We have here time domain or time variables, which is 10-second sample. We have here a variable x, which have the 15 hertz component and the 40 hertz component. So this will be the plottings, and we have here a subplot 211 and a subplot 212. So we have here in subplot number 2, in subplot 211, this is entitled with no aliasing, and subplot number 2, this is where the aliasing occurs. So we will be having here 2 rows, 1 column plot. Then let us see what it looks like. So the critical part here is we will be having use of the functions that we have used in our previous experiments or laboratory exercise. This is the modulation. This is about the modulation. We have used this myFFT underscore plot. So let us copy this and let us see what it looks like in our GNU Octave. Okay, so let us open the GNU Octave application. Okay, so over editor, we will be calling the we will be opening the myFFT underscore plot that we have made. Then try to run this. Then another script for the codes that we have copied. So we will be saving this as OE number 7.1. Okay, so let us see what will happen. Okay, let us wait. Okay, so this is the image of this code. So in here, this is the in the first row, we have the no aliasing, and this is the myFT plot of x and fs1. Then this is the aliasing occur. So this is the myFFT underscore plot of x fs2. So okay. So let us try the item number 2. So let us close this. Okay. Oops. Okay. Number 2. So we will be having here aliasing using convolution in frequency domain. So the first one that we have made earlier is in time domain. Then this one we will be having in frequency domain. So we have here an fs of 44,100 in terms of hertz. Then we have here a tt and psi with a set of variables, with a set of parameters. Then we have here also xx wheel 7.7 multiplied to the exponent of ii multiplied to psi. Then we have here an fs1. This is 3,950 hertz. Then we have here the sample and sample 1 to 3 with sets of parameters. Then sample, which is the sum of sample 1 to 3, or the summation of sample 1 to 3. So we have here a subplot. So basically we will be having here a 3-row, 1-column sub 1-column plots. So this is the first plot is about XSFS. The second plot will be having sample and FS, and the third plot is the convolution. So the combination of these two plots. So let us try to copy this. And what is critical here is we will be using the previous function that we have made also in our previous experiment, the experiment number 6, or the laboratory exercise number 6, which is modulation. So we will be having to use of the myconv function. So let us go again with the Octave. Then try this, and we should have a new script. We will be opening the myconv function in our previous experiment. Okay, then we try to run this one also. And lastly, the new script, the one we have copied, and let us see what will happen, what will be the image of this 311 subplots. So we will be saving this first, and we will be naming this as 2. Then save. Okay. Okay. Let's try to wait, because sometimes it takes time to load for this. Yeah. Maybe it's because of the computer. That is why this may take some time. Okay. So what we have, this is the image of the codes, the image of the graph that was made by the codes. So this one here is the subplot for the xx dash fs and xx and fs. So this is here. This is the 44,100 and the fine. So I am having trouble with this one. Maybe this because of the PC that I have. Then the second one is the subplot for the sample and fs. Then lastly, the convolution of the xx sample 1 and fs. So this is the image of this. This is the image of these codes. So hopefully this concludes my presentation, and hopefully you have learned something from this, and thank you very much for watching. Keep safe everyone, and God bless. Maraming salamat po.